Welcome to NASA Edge.
An inside and outside look at all things NASA.
Today we're in the NASA Langley Research Center model shop where they built all kinds of models, even models of CubeSats.
What is a CubeSat?
You don't know?
I'm learning.
Okay.
A CubeSat is a 10 by 10 by 10 centimeter square spacecraft capable of complex operation in space. It often flies as a secondary payload, but even a primary payload on a space mission.
Now, these 1U CubeSats can be scaled up to 2, 3, 6, even up to a 12U CubeSat.
Now, CubeSats usually begin as models, but on today's show, we're going to talk to students that have moved into the next phase, the design, build, and hopefully launching of CubeSats.
But first, we'll hear from Justin Treptow from NASA headquarters about their involvement with CubeSats. So, Justin, why is NASA so interested in CubeSats?
But when you think about it, like for NASA's purposes, CubeSats have like a couple different advantages, which is why we like them so much. On one side, they're relatively low cost, they're faster, they're smaller, so launch isn't as expensive. And we've shown that you can actually do science with them and you can get data back. Whether it's science or technology demonstrations, they're a really usable platform for getting things to orbit quickly and cheaply. But even beyond that, because they're so approachable, if you want to build a workforce that can support the next James Webb, you can start them on a CubeSat first and they'll get hands-on experience of how to build a spacecraft to a NASA standard, even one that's faster than the big missions we have. Some of our student programs, like CSLI, look to give that same kind of opportunity at a less technical level, but still a rigorous one, to universities and K-12 students so that they can start getting those hands-on experiences before they even get into industry.
So, Justin, what is CSLI?
So CSLI stands for the CubeSat Launch Initiative, and it is a program that NASA runs to provide launch opportunities for CubeSats led by NASA, other government organizations, and student groups, with a big emphasis on student groups. This kind of program looks for K-12 students or high schoolers or college students that have a CubeSat design and show that they have either the funding in place or another partner that's going to help them build it so that when NASA says, all right, the rocket's ready for launch, bring your CubeSat, you actually have a CubeSat to bring. We recognize the kind of hands-on learning that building a spacecraft when you're in high school or you're in college can actually give students. So 95% of the success of CSLI is just having the students bring their spacecraft completed and designed and built to the launch site. Having it on orbit is really the cherry on top of the whole thing.
How does NASA benefit from programs like CSLI?
Well, NASA benefits in a couple different ways. One is we are encouraging like a wide swath of students from across the nation to have an avenue for putting something in space, which in and of itself is a huge accomplishment. That leverages the opportunity for people to put on their resumes and to get into colleges and to continue their STEM education. What we really hope for is that those kinds of experiences early on in their academic career translates into their industry careers. And whether that's going to US commercial companies and building out the workforce there or coming to NASA and working on NASA projects, is really the goal. And these kinds of experiences, I think, raises the tides of all ships.
It's easy to see why NASA is so excited and enthusiastic about CubeSats. With a variety of missions, including space biology, physics and deep space, and even lunar missions where CubeSats are sent to the moon to orbit and gather data, it's quite impressive.
Now, back in May, 8 schools, including 4 minority-serving institutions, participated in the first session of a summer-long program that is designed to help them take their first step into space.
And each of these schools had solid plans for missions for their CubeSats, and we got to hear from them directly about their plans for space. All right, John, tell us, what is your CubeSat and what is its primary purpose?
So the primary mission of our CubeSat is to test an electromagnetic docking mechanism, or e-docking. And so the purpose of this is to simplify the docking process for small satellites, to move away from mechanical mechanisms into a purely electromagnetic or primary electromagnetic design.
So our CubeSat is based on a spectrograph that was developed in a Columbia lab. and it is made to look at diffuse gases in galaxies. Some astronomers estimate that up to 50% of the massive galaxies are made of these diffuse gases, and there's a lot that we don't know about them, including like direction, orientation, and all sorts of dynamical stuff. So the goal is to scale this spectrograph down, put it in our CubeSat, launch it up, and get a lot of really exciting data that will allow us to better understand these diffuse gases and make hopefully exciting discoveries about galaxies.
We are using a single CubeSat to find lunar assets, especially in distress, in times of emergency, or especially with the new Artemis missions going to the moon. Having a way of rapidly finding those easily and cost-effective is one of our biggest priorities.
Our CubeSat is the Space Biology Initiative, and we are growing plants in a closed-loop chamber for testing plant biometrics and stressors in microgravity environments.
Well, our CubeSat is SLECS, S-L-E-C-C-S. It's a space laser error-correcting communication system. Basically, what we're having our CubeSat do is autonomously kind of correct its path, and we're using optical wireless communication to do that.
What I love about these missions is the complexity. Some of the things that we're seeing in the CubeSats are experiments that are done on the Earth's surface. They move out into low Earth orbit and then onto the moon. This is quite impressive.
Now, the one mission that I took interest in came from the Florida Institute of Technology. Now, their CubeSat is going to study the effects of space weather on lunar regolith.
I'm partial to space weather and regolith, so it's a big win. But the question is, how are the students able to do all of this? Well, it begins with this summer's inaugural program, the Missions Concept Program. I had a chance to sit down with Liam of the NASA Launch Services Program at NASA Kennedy to learn more about this program and its partners. Liam, we're very excited to be part of the Mission Concepts program. Tell us, what is this program and how is it helping students with their CubeSats?
Space is known to be hard. The problems are complex, the rewards are very high, but it's going to require the creative ideas from people of all walks of life coming together. And so this is a really great program, bringing together students from across the country and U.S. territories to participate in a summer-long program where they're learning satellite design concepts, and they're participating in a program where they're actually developing their own space missions.
Well, it's interesting because we saw a lot of the mentors working with them, and I'm wondering, all these mentors and people that are assisting them, where are they from and how are they part of this incredible effort?
We have attendees that are here to help, that are from organizations such as the University Nanosatellite Program, which is managed out of the Air Force Research Laboratory. We also have members from NASA, Kennedy Space Center. We have attendees from NASA headquarters. We have participants that are here to help from many organizations and some contractors as well that support those teams.
And these are all folks that have been working in the satellite and rocket launching business. So they're not just encouraging, they're providing real professional guidance and insight.
Yeah, they've been there, they've learned the lessons, sometimes the hard lessons, and they've made themselves available for the students who are tackling new challenges that are, stretching their own understanding, stretching their experience, and they're able to ask a professional who's maybe been there before, what do you think of this solution to a problem? Or what kind of questions do I need to be asking in order to solve this problem?
I also noticed that the students weren't just talking to the mentors and advisors, but they were also talking with one another. This seems like a very important part of the program.
Yeah, exactly. Each of the teams arrived with their universities and they gave a presentation of the project that they're developing at their university. But then they were shuffled into individual small groups to work together for this week in the exercise of developing a mission at the Mission Concepts 1 kickoff. And so they've been able to interact with students from across the country in order to learn how to ask good questions by modeling it for each other and asking great questions of each other.
This is kind of a first for CSLI, right? I mean, we've seen workshops before, but this is a kind of a longer-term approach. What are your thoughts on that so far?
Yeah, and the CubeSat Launch Initiative has always had very much an interest in education. We name each of our missions the Educational Launch of nanosatellites, or Alana. So Alana 1, Alana 2, Alana 3. Each of our missions has education in the name, and we really take that to heart. Some of the teams here have not built a CubeSat before, and this is an opportunity for them to learn what they need to in order to be successful in developing a CubeSat, potentially to fly with the CubeSat Launch Initiative in the future, or with the University Nanosatellite Program.
The good folks at the University Nanosatellite Program have done an exceptional job with the students, developing a rigorous program designed to help them narrow and focus the mission of their CubeSats.
And Blair, they brought a lot of help. Not only are they sharing their expertise with the students, they brought in mentors from the Air Force, the Space Force, the Air Force Research Laboratory, NASA, the Coast Guard Academy, and the Missile Defense Agency.
The net effect? Quite a brain trust of engineering and science for the students. And we had a chance to talk to them about their experiences at the Mission Concepts program.
So here at the University Nanosatellite Program, I'd say the biggest takeaway is just there's been magnitude, lots of information, invaluable information on how to design, how to procure, to fabricate, everything that goes into creating and designing a nanosatellite.
The fact that there's so much work to do beforehand, even just at the basic surface level, is, although very challenging and seems very frightening to a student who's just entering into it, it's really interesting, and I'm glad that I'm able to get a peek into what that's like.
It's okay to say that you don't know. The individuals here do not really expect you to come here knowing everything. So it's like a learning experience and a learning journey. So it has been a great experience so far. One of the biggest things that I realized yesterday, coming out of here, was how much my CubeSat brain is sorted into boxes now. I think for a lot of the year we've been doing a lot of research, but it really felt a lot all over the place. And just by sitting down and going step by step, what are your mission goals and objectives, and all of the subsystems, I feel like I'm so much more organized and I can actually see a path to CubeSat development.
So it's just been extremely informative, and I'm just very excited to be here. Our team is very excited. We're looking to take it all the way to the launch.
This program continues throughout the summer. Next, the students will spend 4 weeks with the UNP at their facilities in Albuquerque, New Mexico. And from there, they'll travel to Logan, Utah for another CubeSat workshop.
These students will continue to work on their CubeSats throughout the summer. And NASA's CubeSat Launch Initiative is celebrating a recent success. Late last year, Thomas Jefferson High School in Alexandria, Virginia, launched its second CubeSat, Reverb. We had a chance to sit down with Kristen Kuko and her students to learn all about their most recent launch and their latest efforts. Kristen, can you tell us a little bit about the high school's relationship with CubeSats?
Sure. So back in 2013, TJ3sat was the very first high school satellite to be launched. It was a work of about 50 students over the course of 6 years, where they essentially built a CubeSat from scratch and launched it into space. Its goal was to say hello world, and it didn't quite make it.
Well, but you still launch, which is an incredible accomplishment.
Absolutely. It's one of those things where it would have been nice if it worked, but it's even cooler that we got something into space.
Well, and I tell you what, it's also important that things didn't stop there. I mean, you might have had a few bumps in the road, but you guys have actually moved on and worked on another CubeSat. Can you tell us a little bit about that?
Sure. In 2017, another group of students decided that they wanted to do a CubeSat again. So they put together a mission, and then they applied for the CSLI grant and got it and started work on their next CubeSat, which was TJ Reverb.
Say hi to the camera, please.
So, Coy, what is Reverb?
So Reverb is a 2U CubeSat built by TJ students, and its goal is to test an experimental iridium radio in space with our passive magnet stabilization configuration.
Iridium, that sounds like something out of a Marvel movie like Captain America. What is that?
So Iridium is actually a system that's a bit more down to earth. So it's basically a satellite phone system that you and I can go out and buy. And we're seeing if we can leverage that in space, since it's cheaper and easier to use. So future teams can leverage our work to be able to launch CubeSats more cost-effectively.
So on Reverb, what was your responsibility with this project?
So I was the programming lead. So I was in charge of a lot of the flight software, both high level, and I also worked directly with Alan Su who was the electronics lead, to be able to integrate the programming side of it with the electronics side, since the programming side was about interacting with the hardware in a way that could make the mission work.
Alan, your turn. Hi, okay.
So Alan, Corey tells me you were the electrical engineering lead on Reverb. Tell me a little bit about what you did with this project.
So a lot of it was figuring out how things worked. When I came in, there was a flat SAT, so basically the whole thing disassembled and put flat. There was actually a few wires that were broken, and the board that we designed was actually designed wrong. In the fall of that year, I've spent basically a few months just redesigning and iterating on that interface board and just getting it flight ready. And we used an Iridium radio, which kind of acts as a cellular plan. So you actually get an allotted amount of data every month. For us, it was 12 kilobytes. So we found that we really shouldn't be sending our data in string packets. We should try to compress it down. So I actually designed an encoding protocol to take numerical data and turn it into the smallest form it could be.
Now, launching a satellite is a big deal. Were there any challenges that you encountered during this process?
Yeah, there were a ton. We couldn't put up an antenna on the roof, so we worked directly with ham radio operators all over the country and all over the world, as well as with the U.S. Naval Academy, to be able to contact the satellite.
Now, it sounds like a lot of what you did was on-the-job training. You were trying to actually feel your way through this entire process. Is that what it was like?
Yeah, that's basically it. I've never worked on a satellite before. I was in the club the year before, but we were working on a weather balloon project. But that is actually where I learned how to design PCBs. So there were elements of things that I learned beforehand, like projects that I had previously worked on that kind of applied to this project in new ways.
The last screw.
Well, even considering those challenges, you guys did a good job in getting the satellite launched. But in the future, what would you do differently, or what would be beneficial to help you and the students be even more successful with their CubeSats?
I think the simple answer to that is mentors. Having the people who know what they're doing, helping the students directly, having an opportunity to kind of learn about what the process looks like before you get started. Because a lot of the issues that we ran into were because we just didn't understand how CubeSats actually got deployed or how they got together, got launched in the first place.
Springs on the bottom. And so the spring plate will be compressed. We'll put the lid on, and then you tighten these rods that go.
And just knowing those little bits and pieces of information probably would have helped the things go a little bit more smoothly.
Now, Reverb was deployed in December of 2022. That project is done. You have just a short time until you graduate. How much will you be able to be involved with this during your senior year?
I think that a big part of my job as a senior is to be able to bring up the next generation, because I only have one more year. And it's important for me to be able to offload my experience and my knowledge to all of these new freshmen, sophomores, future juniors, to be able to do even bigger and greater things in the future.
You know, Blair, I'm really impressed with these kids. When you speak to them, it feels like you're speaking to a NASA engineer. Their understanding of the information and the technology and how they bring all their individual expertise together to overcome obstacles, it's really amazing.
It really is. And in fact, I almost called one of them doctor. It was a visceral reaction, but I couldn't help it. Very impressive kids. But despite all that, they would have really enjoyed the Missions Concept program. And as they go on to university, even postdoc, maybe they could apply and our paths will cross there in a future launch.
Well, that's the end of our show today. We'd like to thank the UNP, their many partners, the mentors in the Launch Services Program for coming together and helping these students learn more about CubeSats in space.
And hopefully all these schools will have their CubeSats manifested and ready for launch in the near future.
And bonus, if they launch, we can cover it.
You're watching NASA Edge.
An inside and outside look at all things NASA.
Dude, I stepped on your line.
Well, we're out of the show anyway, so bye.